Hey guys, welcome. Sorry I haven't been there for the last 2 days, but we make do with what we got. So this is your warm up for the day. Go ahead and pause the video and work on this warm up. It's fairly simple, so it shouldn't take you a long time. Um, so go ahead and pause it now. Okay, so number one, the rectangle and has a length and a width of this. What represents the area? Area of a rectangle is length times width, so you just multiply the two together. So the first way I wrote it in blue over here on the left is the traditional way of multiplying the numerator and multiplying the denominators, and you get 14 over 24, and then you just reduce because they both have a common factor of 2. So you like divide them by 2, divide them by 2, and they give you 7 over 12 centimeters squared. When you do area, it's going to be a square because you have two dimensions, so it's a square. Um, the more appropriate way for what we're going to be doing with multiplying rational expressions this week is going to go when you multiply fractions, you can cross cancel or cancel from the numerator to the denominator. Um, so here, 2 and 8 both have a 2 in common. So 2 divided by 2 is 1, 8 divided by 2 is 4, and then 7 times 1 and 4 times 3, which will give you 7 over 12. This step right here, I typically would never write down. I was just showing you kind of how you multiply across after you've canceled stuff out. So we have a square down here for question number 2 with a perimeter of 17. A square is the key here. They're all the same side. And so we had like x times x times, x plus x plus x plus x. That's x 4 times, and it gave us 17. So if you just divide 17 by 4, that's how you come up with one of the lengths. It wants to know what is the area, so you need a length times the width, or the length squared. And that gives you 289 over 16, because you multiply the numerators. They don't have anything that will cancel, so then it will leave you like that. Another rectangle has a width of this and a height of that. Write the expression that gives the area of the thing. So you just multiply the length and the width, or the base and the height, or the width and the height. It doesn't really matter how you word it. You just multiply the two together. And so you get 3 times x, and 2 times 4 is 8. And since they're meters, it's meters squared. There's not anything that would simplify here, so you're done. Okay. So today we'll be simplifying rational expressions in their simplest form, and then we're going to multiply and divide rational expressions. But through the division, we will be only multiplying, basically. So when you're multiplying rational expressions, step 1 is you need to factor everything. Get it into its most basic form using the factoring stuff that you did yesterday from the warm-up. If you need help with factoring or anything like that, you can go to my website, go to the Math 1 page, and then look up the factoring, and I have a bunch of videos there as well that'll help you break it down. Or you can go to YouTube and look up a bunch of videos on top of that. Then we're going to do the canceling thing that we talked about before, when you can go from the numerator and cancel something to the denominator. Okay? Then you're going to rewrite your answers, and you're going to write restricted values of x. Okay, and we talked about that a little bit yesterday with the anything that's in the denominator. You just set it equal to 0 and solve for it, and x can't be that. So the thing you need to know here is anytime something's in the denominator at any point in time, you have to restrict it. So in this particular example down below, we have two things that are in the denominator, this one and this one. So then we would need to find the zeros for that, and x can't be those two things. Okay? So we'll go ahead and solve that one, and we'll see that we have an x plus 3 in the numerator and an x plus 3 in the denominator, so those two will cancel out, and leaving you with the x minus 2 on top and the 2x plus 3 on bottom. And we can't have x plus 3 in the denominator and 2x plus 3 in the denominator equaling 0, so we figure out what their zeros are, which is essentially the opposite of it, and then the opposite over coefficient. Okay? And so these are the restricted values. This is the answer. Okay? Um, so your first example, I guess, that you're going to do is this is one where you have a rational and it's multiplied by a whole number. The way I want you to think about it, being the honors class that you are, is anytime you have a whole number, it always multiplies to the numerator. The reason for it is you can rewrite the second term here as a fraction, and that makes it 8 over 1, okay? And then you'll multiply the expression into a single form and then check for anything that could make it not equal to 0. So we've taken the 8 right here, put it over 1, and then that does 3 times 8 is 24, 1 times x plus 1 is x plus 1, and you can't have this equaling 0, so you subtract 1, or you get negative 1, and so this is your full answer right here. But for me, just make sure that you know that a whole number multiplies to the numerator always. Okay? So example 2, a little more difficult. If you feel like you got it and you want to go for it, awesome. Pause the video. Pause it now. Try it. Okay. Welcome back if you paused it. If you didn't, I'm going to show you how to do it. I'm going to go ahead and put the answer completely on the board so you can copy it down. Alright, so the first thing I did was factor this the numerator and the denominator on this side into x plus 6 and x minus 3, and x plus 5 and x minus 3, and then I factored the numerator and denominator here. So make sure, again, you know how to factor. It's going to come super in hand, become super handy right here when you're doing this. Alright, so now that they're all in factored form, anything that's in the numerator can cancel with anything that's in the denominator. So like the x minus 6 right here can cancel with this x minus 6. The x plus 5 can cancel with this x plus 5. The x minus 3 can cancel with this x minus 3. The x plus 6 can cancel with this x plus 6. And everything cancels away. So theoretically, like if you had x plus 6 over x plus 6, that equals 1. So essentially what we have is the same thing over the same thing. And so it cancels out and gives us 1. And then all of these numbers can't be in the denominator. So you had x plus 5, that gives me the negative 5. X minus 3, that gives me the positive 3. X plus 6 and x minus 6 gives me positive 6 and negative 6. Okay, so these are the numbers that x can't be, so your answer is all the stuff in pink right here. Okay, in this example, same basic principle, factor everything, okay, and then cancel, and rewrite your answer, and then write the things that it can't be, your restrictions. Okay? So here's the answer right here. This is a basic factoring where you have a binomial. Typically when you have a binomial, you either check for difference of squares or if they have a common factor. They both have a 2 and an x squared. Always go with the lower exponent if you're doing just that. Okay? And so that factors down into that. I would go ahead from this point right here and try to write down some of my restricted values. Whenever you have an x outside the parentheses, it doesn't have a plus or a minus or anything like that. It's always 0, so that's where that 0 comes from. And then you get negative 1, negative 3, and then negative 1 again. Well, we already wrote it, so you don't have to rewrite it. And then we go down here and we cancel out. So the x plus 1 cancels with the x plus 1. This x plus 1 cancels with that x plus 1. This x will cancel one of those x's out. So there was 2 here, and so we left with 1. And then the 2 stays because we don't have anything to cancel, and neither do these. So when we multiply it across, you got 2 times x plus 2, and x plus 3 is just on bottom. And you want to keep your answer in the factored form. Don't try to multiply this back out. Okay? I believe every answer that we get will be in factored form. If not, I know you guys know how to multiply that out, so don't worry about it. But for me, leave it in factored form. No problems. Okay? Alright, so now we're going to dividing rational expressions. Okay? So review. How do you divide fractions? Okay, so you look at this. Many of y'all may know keep, change, flip. not my favorite terminology, but it works here. So you'll keep the first fraction the way it is, change this to multiplication, and flip these two around. Okay? And so when you do that, you'll come over here and you got 1/6 times 3 over 5, which equals 3 over 30, which is 1/10. Or you can see that the 3 and the 6 each have a 3 in common, which makes that 1 and that a 2. 1 times 1 is 1. 2 times 5 is 10, giving you the same exact answer. Okay? So now, the steps for dividing, you may have to pause because I'm going as fast as I can to keep the video time limit down. Okay? Factor everything, determine your restricted values, keep, change, flip, add more restricted values because the top now became the denominator, cancel, and simplify. Okay? So let's practice this one. Go ahead and factor everything, keep, change, flip, identify all of the different possible restricted values you could have, and then cancel and simplify. Pause the video now. Welcome back. So this is kind of what you should have looked like. We factored everything. We're going to flip-flop these two. I'm going to go ahead and write my restricted values. So -6, +3, okay, +5, -6 I already got again, okay, and then when we flip-flop it, these two will become the bottom. So basically everything in the divisor will become restricted. And so you got the +4 and the -5 as well. And so all 5 of those numbers will be restricted. Okay? And once we flipped it all, the x minus 3's cancel out, the x plus 5's cancel out, the x plus 6's cancel out, leaving us with these two I guess binomials right there. And so our final answer is this. Okay? So you guys practice this one on your own. Pause the video, work it out, and see if you got the same thing that I got. And welcome back. So the final answer should look like this. Okay, make sure you have the same restricted values. Make sure you've reduced it down the way I have it reduced. Okay, and you can just double check. Alright, here's another one for you to try on your own. Do the best you can. And pause, unpause. Cool. So you factored this down at the top, the bottom, okay, everywhere. You wrote down all your restricted values off to the right over here. You flip the numerator and the denominator of the second one, and then you should have stuff that cancels. A lot of these factors look like they should cancel when they first start, and they won't at the end, and that's done on purpose to see if you're going to try to cancel them out. The x minus 6 and the x minus 6 can't cancel because eventually the second x minus 6 will be in the denominator, and thus it won't cancel. Same thing with the x minus 5. It looks like, yes, it's going to cancel. It's going to be a really simple answer, and it doesn't because it goes into the numerator and makes it uncancelable with the other one. Okay? So just be careful with that one, and you should get that same factored answer that we have at the end over there. Okay? That's the last slide of this video. I think I kept it down way less than the one before. Your classwork assignment is underneath this video link that you had in the website. I don't care as much about having the puzzle answered as much as you do the work. You have to write all the work down, and I need to be able to see it. It needs to be neat and in order. So make sure you do that. Alright. You guys have a good day, and I'll see you tomorrow.